Hello, everyone. Thanks for joining us today. I'm Harpreet Singh, your host, and I'm excited to have you all here. In today's webinar, we'll explore how AI is shaping evidence management and investigations. Every investigation starts with a question, but finding answers often means digging through massive digital haystack, video, file, voice recordings, emails, social media, and many things more. The challenge? The haystack is measured in terabytes and petabytes. So let's get started. The chat is open. Please feel free to post your questions as they pop up, and we will address those in the end. I'll take this opportunity to introduce our panelists. David Press, Technical Sales Specialist for Object and AI at Hitachi Vantara, and Hemant Vishisht, CTO at Audax Labs with over 25 years of experience in data and AI. Welcome, gentlemen.
Welcome.
Hemant, to begin with, the question that comes to my mind is people often think digital evidence management and investigations are same. What are your thoughts?
Well, it's quite common, but digital evidence management is the enablement engine for investigations. It is a combination of software and infrastructure, which helps in data collection, storage, indexing, security, and discovery. Investigations, on the other hand, are the activities performed by investigators for a specific case or matter in order to find evidences, perform analysis, and derive conclusions. So without evidence management, your investigations, will be very, very challenging to perform.
Right. And we're seeing exponential data growth. What kind of challenges it creates for investigators?
You're right. I mean, not only that, data is growing, but of course it's growing everywhere. But and we have seen many cases where which contains media files like probably drone footage, body cam footage, or data coming from devices which are drastically increasing storage and processing needs. However, for any investigation, data collection is the starting point, right? And followed with analysis of data to identify relevant data to the case. So the first challenge is to collect data from these diverse sources. However, working with these, this type of data can be very challenging. Even if the data is either maybe a legacy sometimes or in different language. And you can think about if we are scrolling through millions and millions of documents, and believe it, sometimes the cases can contain that kind of data. And without the right indexing or AI capabilities, you will end up wasting a lot of time before even starting the real investigation. So if we talk about law enforcement, investigators often work with forensic tools like Celebrite to extract data from mobile devices. And this data contains call records, messages, WhatsApp chats, media, documents, etc. Collecting this data is a challenge, but the biggest challenge is to process and prep this data for investigation. And without a competent evidence management system, investigations can be extremely resource intensive and time consuming. So to answer your question, I think the biggest challenge for the investigators is just the sheer volume of unstructured data.
Coming to you, David, as you know, the data volumes are exploding. How can organizations optimize their data centers to handle growth?
Sure, and it's a good question. And not only is the data growing, as Hemant said, that a lot of data has to be processed. So even in the processing of data, you're creating even more data. So it starts in the data center by providing a cohesive data and system management ecosystem, right? Data volumes expand on-prem, but also in cloud environments, remote offices, user devices. And Hitachi, as a supplier of solutions that include the full stack from software to compute and networking, all different types of storage, block, file, object. We realized that we need to help our customers manage the systems themselves and the data that is stored across them. So we've actually announced a product called VSP 360. So this is a unified platform that manages our VSP1 storage portfolio, which includes on-prem, public cloud, and hybrid environments for block file, compute, and software-defined storage into a single platform. So this streamlines with AI-powered automation, observability, and lifecycle governance. So this creates a centralized visibility, intelligent protection, and a kind of infrastructure as code capabilities. And by the way, this also works with third parties because obviously our customers have all different types of systems that they need to manage together as kind of one ecosystem. As far as optimization, so we provide like on our block storage with a guarantee of 4-to-1 compression. With object storage, which is really essential as evidence and data grows exponentially with unstructured data. The most efficient place to store that is in object storage. And with a VSP1 object, it's now more high performing, more scalable, and it provides the efficiency in storing that data, as well as providing the types of capabilities that we need in evidence gathering, meaning we need to be able to protect and secure that data. So by doing that and also like classifying a data, intelligent placement of that data to make sure that the right data is stored onto the right type of a tier storage, that will help our customers, grow and optimize their environments as the volume of data grows.
Can you share an example where modernizing the data center helped organizations to optimize cost and they were able to improve the efficiency?
Sure. Now, I know a lot of our customers have provided us feedback that they are saving on their storage costs because of the way that we're able to compress the data. Also, with the density of our systems, they're able to store more data within a smaller footprint, and that saves them. But also, we're able to classify and index data. It improves the ability to actually search and collect data. So we have a bank that had a big challenge on doing custodian search. Sometimes these searches, and they have many of these every year, can take up to 2 weeks or more to do a search for custodian data that needs to be turned over. And so we cut that down until just a few hours, and oftentimes those searches can be done within just a few minutes. So that user's productivity is much greater improved, as well as the data that's collected is more defined and smaller. So we're helping our customers grow data slower, right? That's essential. We also have a law enforcement task force that has reported back to us that they're reduced their searching times by 70%, and they said that they've saved about 40% on their storage costs by moving the data that is cold onto an efficient object storage and keeping only the hot evidence onto like the high performance flash storage.
Yeah, that makes sense. Coming to you, Hemant, what are your considerations for designing an AI solution?
It depends on the industry and the expectations of the customer. If we talk about BFSI, the majority of data is either office documents, emails, messages, etc., with very little media content. For this type of use case, the first step can be just traditional, breaking the silos, do indexing and allow faster searches and discovery. This can be further improved by aiding, Gen AI capabilities to provide summarization or translation, classification, and so on. On the other side, if we talk about law enforcement, the data demographics here changes completely. Now, as I mentioned before, we are now talking about more media intensive. It could be body cam recordings, it could be CCTV footage, it could be device or mobile data, forensic data, for example. So for this use case, in addition to what we are already doing for BFSI, we also need to plan for capabilities like speech to text, sometimes object modernization, capabilities around image searches, etc. So for these different use cases, we need different infrastructure and different AI capabilities. And I'll give you an example. So we were working with one of the large bank, and they wanted to reduce their dark data, and they had a few petabytes of historical data with around 200 terabyte annual net new data. So we worked with them, to suggest and provide information about what infra needs are to ensure that we are able to process the historical data within 8 months, because they had a hard dead timeline. Because sometimes the if you work on in the BFSI industry, the regulatory timelines can be very, very stringent. So we were able to process all that historical data within 8 months, and again along with managing the net new data. So the best approach is to work with customer to decide what are their expectations, and design your system for streaming as well as for batch processing. And this way the solution can adapt based on the changing business needs.
Mm-hmm. Mm-hmm. So, David, what should organizations prioritize as part of their AI roadmap?
So I think that there's different parts of the way AI is coming into our environments, right? I think I see a lot of AI organically blending into our ecosystems without even much planning. And so more and more applications, just like even with, like I mentioned, VSP 360 incorporates AI. A lot of the tools that, software tools that we produce incorporate AI, as well as other softwares. It's and it's almost it's being included in the products, again, without necessarily much planning. So what our customers, what we see them doing and what they need to prioritize more is compute acceleration, right? AI loves GPUs. And oftentimes when AI is incorporated, we're working with our customers and trying to figure out, okay, I need to buy this GPU and how much time will it need be used. So what I'm seeing is that they're starting to incorporate more GPUs into more servers, even without necessarily having that specific project in mind, because they know it's going to come, and that's important, right? So a percentage of their servers need to have GPUs, so that as the applications and tools need them, that they will be available. And then because you also need to have high performance networking for these systems to be able to communicate, there needs to be a priority in advancing our customers' networks, and again, as well as doing high performance file. So as you're doing high performance computing, you need file systems that can keep up. And the traditional file systems, while high performing, they're not performing enough for those AI type of workloads. And so again, what I mean is like a parallel file system. So those NVMe clustered servers with a software running on it that is extremely high performing. And by doing that, actually, you don't necessarily need a large amount of that if you do it in combination with an efficient storage where the bulk of the data stays while it's not being accessed. So a lot of our customers are utilizing high performance file with an object storage in their AI ecosystems. And then, AI can't be siloed, right? The data if it's unavailable, it's not part of the environment. And what we've seen more is customers needing to prioritize actually processing their data so it can be available, meaning that we see a lot of customers with older file types, and they need to process that data to modern the file type. Also, as Hemant mentioned, processing the data for like audio transcription, OCR, so that data can be included in the AI tools. And then you have the modeling. So you have the piece where you have AI that is organically in the tools and the applications and used for outcomes. And then you have is is a customer needing to do modeling based upon their data so they can improve what type of outcomes they can get from their specific data sets. And then the other thing that I see as well is movement of data. Companies are now prioritizing, again, getting access to the data, moving the data off of, say, tape, so that they can actually move it into like an object storage so it's available to them, as well as I see a lot of customers utilizing digital asset managers and media asset managers more as well.
Right. So, I'm hearing a lot about it's all data dependent, and we need to touch on this very important point that's coming to my mind is the legacy systems and the old data. So, Hemant, how can AI deliver a quick win without a rip and replace?
Well, I think what David talked about, that obviously there is a lot of legacy systems, data types as well, and again, it's very common as organizations grow. They add locations, systems, or go through various mergers and acquisitions, resulting in silos and legacy formats. As I mentioned before, the quick win is to break these silos by creating central indexes. Now, just to talk about, we all use Google for searches, which provide results from millions of these websites. However, Google doesn't move the data. All the data still stays on their specific hosting servers. What makes Google powerful is the central index of this data for searches. And this is exactly the very, very quick win any organization can do when you're trying to break the silos, that you can bring this data into a central index, which allows faster searches and discovery. Now, coming to AI, we should focus on models which can add layers of additional metadata, for the discovery, and this can be very, very specific to the use case. It could be summarization, it could be classification, it could be speech to text, or OCR, for example, or image search capabilities. And if I just want to touch base that we have a product called Data Beagle, and what it does is it connects to a lot of different file shares, email archives, object storage, or even applications like SharePoint, and to perform entity extraction, automated tagging to help in natural language search as well. So this allows to bring value out of your existing tech stack. Now, the logical next step from here will be to invest in solutions like VSP1 file, as David mentioned, from Hitachi, which allows organizations to centralize their distributed data.
So, looking ahead, how do you see AI fundamentally reshaping investigations?
I'm saying that it's not just evidence management. I'm saying that impact is on all industries. What we are seeing is movement from reactive to proactive. We are currently using AI for specific functions, and I'm sticking to the evidence management use case here, but functions like speech to text, image search, or summarization. All of these actions are focused on aiding the investigators. Now, from here, we are seeing more and more proactive AI interventions using agents. For example, as an investigator, if you're working on a case, and if you provide your case description, object or entities of interest, the agent will start discovering data, and it provides a relevancy score to the object based on your case. And at the next level, it can add these objects to a collection or an e-case board for further review. Now, I just want to add a new challenge which is emerging here due to the very realistic deepfake content, which can be clouding the investigation if it is not identified. So I also see AI's role in identifying and countering this type of data. Just to summarize on this one, it doesn't mean that we don't need traditional models. We still need them because, believe it or not, we can't throw large language models to every problem. So we still need traditional model. We need them to help the agents perform these next level of activities for holistic solution to reduce the workload and time of the investigators.
Right. David, what new demands will AI applications put on our customers' data center and their environments?
Sure, it's a good question. So first, as we mentioned, the need for compute, right? They're going to have more kind of burst computing, model training, low latency type of inferencing, and large unstructured data repositories. Networks need to handle the parallel data streams. And think about like the ingestion of data off of like body cams and OIT devices and forensics. But also, one of the bigger challenges as like tools like Data Beagle need to be able to get at the data. So we mentioned we need to process the data so that it's indexed and searchable, but we also have to get to the data that is not in the data center. A lot of evidence, and actually probably I think it's even more than 50% of the data is actually produced at the edge. Right, so we have to get that data so the tools like Data Beagle can process that, and that can be tricky. So we have remote offices, we have user systems and devices, as well as cloud and public cloud. And so we need to be able to get that data accessible to these tools so that it can be part of the evidence gathering. So gateways are great for this, file sync and share. We produce one called Anywhere Enterprise, and this is a great tool. A lot of times, customers using this again to get that data off of the person's machine that's at a remote office, off of the shares in remote offices, off of devices. I think of somebody gathering evidence at an investigative site off of the device. And so this type of tool, Anywhere Enterprise, can actually pull that data back to the data center and make it available for tools like Data Beagle and others to again process that data. It also provides capabilities like setting retentions and securing that data so that it can't be tampered with. So I think that's a big key to it, to getting our environments able to handle these types of demands.
Yeah, just to add on to what David just said, I think the key to this is, Harpreet, that how these systems are really transparent to the users. They would still use it like traditional file share. They don't really know that the data is going to a central location. So it is really key to success of any tool or hardware, that it does not fundamentally change how users work. So it just blended.
Right, and I've had customers that have mentioned that this is a big challenge for them, is that a lot of these users in remote locations are producing data that they don't have control over. So it is an ongoing issue as to, it's not just on the evidence, but they don't have any control over it at all. So it is important to be able to pull that data back. Again, like Hemant said, the user still has access to a local copy of that object, but then the organization gets to include that again in its evidence gathering, make sure that's secured, make sure it's protected, and make sure that it's not lost.
Right. Thanks for a good insight, Hemant and David. So I want to circle back on one thing, Hemant, that you talked about a little earlier on generative AI and agentic AI. What capabilities do these unlock, and what are the risks that come with them?
Well, I mean, as I mentioned before, generative AI primarily can help with, and I'm focusing more on the evidence management and investigation side of the world, but it can help with, think about sometimes, we are dealing with a very large documents. So it can help with summarization, pattern matching. And there's a big challenge for the investigators that if the evidence is in different language, so they need to find capabilities to translate that that object. Now there's a lot of risk sending this data out for cloud for translation, so to speak. You can't do that because of the privacy nature reasons. So of course, translation is one capability, ability to perform pattern matching or finding information where On the other hand, agentic AI is all about taking actions based on the discovery or the information which has happened. Uh, Now, coming back to the risk with LLMs, right? So the risk lies with the data they are trained on, and these language models are trained on generic data, so they lack specialized domain knowledge. They often have difficulty in understanding, context-specific terminologies for, let's say, law enforcement or evidence management or sarcasm, which can lead to inaccurate results. Now, another risk is, and this we have seen very often, and it is not only into the evidence management, but in general, we have seen uh, people reliance on the results coming out of generative AI, right? They assume that LLM outputs are correct just because it is well structured and well written, and that leads to overconfidence bias, right? So one need to be really careful in implementing generative AI solutions. Now, I'll just take an example that, with Data Beagle, we use generative AI in a very, very specific way, uh, just to classify, summarize and assign probably relevancy score to objects, which helps investigators to quickly focus on what is relevant. And it is very, very big help just to, and people who work on cases, they know that there are millions and millions of documents. And if we can get any kind of help to tell them, these are the objects looks relevant to what you're searching for, it's a big help. At the same time, it uses agentic AI to perform, specific actions like automatically applying retention for relevant or classified objects to protect them, from any unwanted deletion.
Right. So coming back to David, how can organizations protect data and ensure that it is the evidence that is tamper-proof?
So it's important that an organization have immutable storage. In the past, this used to be provided by either tape or optical drives, right? And then was the birth of object storage, right? That provides that type of capability that is immutable, meaning that the data can't be changed and it can't be deleted. So that's an important element. I was talking to a bank actually who was utilizing something to lock data and writing it to like a NAS device. Well, the software may protect kind of the link to the data, but potentially someone getting access to NAS could actually delete that data. So an immutable storage, meaning data that you need to be able to assure in a court of law that the data could not have been changed. It could not have been deleted, and no data could have been added, right? So that's an important piece. So like VSP1 object is that an immutable storage, right? And it's part of the ecosystem. You're going to need to have the parallel file systems. You're going to need to have block. You're going to need to have file, but you're going to also need to be able to set a legal hold and set retention on this data, as well as like distribution service, which so some organizations require that data, when data actually reaches its the retention period, that it actually get removed. In fact, we've produced a tool for some customers, data retention enforcement, which says if certain criteria has been made, like data has not been modified or changed, and is not part of some kind of tagged, some kind of business relevance, that it needs to be deleted. Right, because it ends up creating a liability for having all of this data. Think about when you actually do need to process data, you need to find data. If you have a lot of your data, which we call dark data, which is not business related and not relevant, it slows down your ability to actually funnel through all that data. So it's important. Again, an immutable storage like a VSP1 object it's really core to having the ability to lock and make sure that your data is tamper-proof.
That's right, David. I think I'll just add a little bit onto this. So before the data is on the object store for tamper-proofing and everything from that perspective, think about solutions, Harpreet, where we are collecting this data from different sources, and the right system needs to have fingerprinting or hash matching of that object right where we are collecting from the source. So what we need to do is, when we are collecting the data and we are let's say ingesting into object storage, so there has to be a right kind of annotation, the right kind of audit, which says the data which is collected and the data which is into the object stored is exactly the same. So that is the first part of it. Now, the second part is you need systems which are providing you the end-to-end audit trail. Like, for example, Data Beagle does that. So anything which you do on the system, on the object, whether it is adding a tag, you're doing a search, you're doing let's say an export, or anything is done on the object is available, as an audit trail. And this audit trail is also immutable. So you have end-to-end tamper-proof data, as well as a proof of what has been worked on, who has worked on this data. So this way, if you need to provide any evidence that okay, this is the exact the data we collected and this is the exact data we have produced, so we have everything ready.
Well, yeah, thanks, David and Hemant, for clarifying that. It was a very important factor, I suppose. Moving to a very important factor, and we're talking about, we touched a little bit on infrastructure, people and culture. So what people skills and culture shifts matter most, to make AI effective and be able to produce great results as part of that?
So I think that using AI is going to be second nature because it's going to be embedded again organically into pretty much everything that we do. I think one of the important things is to be able to constantly check and balance on what the results of the AI and the generative AI are producing, right? So today, people are trusting some of the conclusions that AI provides, and it's not always accurate. So there's going to be, I think this is where part of the culture change, I think, in IT will be to test the models, test the accuracy of the results, because and there are lots of cases where it's AI produced something that was not actually accurate. It drew conclusions that were not legally correct. So it's going to require, because people using these are going to trust it. So it's going to require the kind of these checks and balances that are ongoing to make sure that that the results are accurate again, are producing the right types of results.
That's true, David. I think from the way I look at it, that it's people have really started using AI in a big way, right? Now the problem is, what we need to aim for, that whatever we do, it needs to be really transparent to the job or actions what the users are performing, and that way there is not a big change. But in my opinion, if you look at the kind of data which is being generated today, right, and it is humanly impossible to really process and make sense of the data if you don't have AI assistance. So you need to have, there's no getting by this. And all the people working in the field, they appreciate that and they understand that. So in my opinion, there is no big clash here from that perspective.
Right. So David, what does Hitachi's current tech stack offer for the customers that they can use today?
Sure. Well, across our portfolio, we have AI-ready systems, AI-ready storage. We have GPU-powered compute and orchestration tools. Our VSP 360 provides AI-powered and management and visibility into the whole environment. We also have Hitachi IQ. So we've been talking about how AI is utilized organically, kind of like in applications for outcomes. But then we have the other part of our organization who has a purpose-built AI stack, which includes the software and the hardware the networking, the storage, the parallel file system, so that an organization is not trying to put together a system that will work for them, and then not be sure that that's going to work, right? So we have a consultative group that will actually work with our customers to figure out on the modeling and training of their models, how they can do, what they might actually, how they will actually do that. And then again, like I said, we have that full infrastructure stack that the customer can purchase that knows that's going to work for what their use cases are. And that's called Hitachi IQ. Again, it's consultative kind of AI defined solutions and expertise in helping, assist customers in their modeling initiatives.
Right. Well, David and Hemant, thank you very much. Although I have many questions popping up in my mind, but in the interest of time, let me take a few questions from our audience. So, what do you mean by data immutability?
Oh, well, I guess I'll start with that one. So immutability, what we're talking about when I was talking about like the chain of custody and tamper-proof, is immutability means that data cannot be altered and it cannot be deleted, right? Not just from an application, but even from an admin gaining access to the system, right? So you need to make sure that nobody can actually change that. There are hashes done, there are tools to make sure that that does not happen. And like the object storage is to the kind of the DoD standards of protection levels. So that's kind of the what immutability means. Not access to change it, not access to delete it, and not access to add to it. So if someone sees that they can potentially add something to a data set, and that can be included in the data set, they can alter something. So that as well, like you can't write data to a system unless you have the appropriate access to do so.
Got it. Right. Before organizations embark on their journey on AI, where is the lowest risk and the highest return? What is the starting point for that?
I can take that. So, well, I mean, we should start with AI, discovery. And I think just to ensure that we have right data, tools, and infrastructure to begin this journey. And as David was talking about, we along with Hitachi IQ, help many customers on this path. At the same time, as I mentioned before, we should focus on data pipelines to bring data in the central place for discovery. Prioritize, one on pain points and data readiness based on your industry. Focus and start with very specific use cases. Now, one caution I would like to give here is that avoid large upfront investments and create a roadmap for your AI journey.
That's a good advice. The next question, let me understand this question. So yeah, what are the strategies to mitigate risk for using LLM models?
I mean, we covered this a little bit, but and I'll just stick to the discussion here about the investigations and evidence management. So data security, in my mind, is of highest importance, and using on-prem or private cloud hosted models can greatly reduce data leakage or that kind of risk. Now, other risk is about bias, and we touched about that. But having human in the loop can reduce that risk drastically as well. But apart from all that, David touched upon this a little bit. We need to also consider not only just the evidence as a immutable storage, but also the logging and logging of the result outcomes to ensure that we are able to audit what was the queries, what were the results, and we can ensure that, and we can fine tune if required from the models, whatever is coming out.
Yeah, I think also we're going to need to be able to trace back, right? So
Yeah.
as AI is used and as results are provided, again, like why did the result turn out the way it is? That's why, like when we're doing like summarization, we're doing transcoding, classification. You have to be able to again tie back why was the classification done, where was the summarization found, that type of thing. So and again, like auditing, it's always going to be necessary to audit the types of results that we're getting, and fix, right? So we're prompts. So I think when we talk about like how people are adjusting to AI, and how we can potentially train people to do better, it's in the prompting, right? How to write a proper prompt so you get the right type of results. And again, as we go forward, a lot of that prompting will be provided by IT and those of us who are, again, blending AI into our products.
Well, thanks, Hemant and David, and to all of you in the audience.
Thank
Well,
you.
3 takeaways. Start small, secure your evidence slate, and keep AI transparent. The recording and the slides will be available in your inbox later today, and the speaker's LinkedIn addresses will be available in the chat. Join us next month for another exciting session, and stay curious, stay safe. We're going to end this broadcast now. Thank you very much, all of you.